Hey guys, welcome to a new project Euler tutorial. This is problem 22, name stores, using names.txt. Basically find the name store. So, I'll walk through this step by step. Save link as. I already have this saved. You want to go to where you saved what you called it. I called mine project Euler 22. So just go in here and just hit save. Don't go into any of these files or it won't find it. So I'm going to cancel out of that so I already have it saved. Open up NetBeans. Since we're reading from a file, you're going to need to import IO file and file not found exception. Whenever you read from a file, you always need to put it in a try statement and read the file not found exception. You're also going to need to import array list and list to hold the names, and then a scanner to read the file itself. So let's get started. You're going to need private final static file names file equals new file, and what you need to do here is go to where you have that file saved. Copy down the address. I didn't think you needed to do this, but apparently you do. Oh no. Let's try that again. Sorry about that, guys. Things are just not going well today, let me tell you. There we go. I didn't think you needed to do that, but it didn't work for me before, so I'm just going to do that. So private static void main, we're going to need a list of type string to the names. And we're also going to need a sum. We'll just call that a long. So here's where we're going to read from the text itself. We need to put it in a try statement, just because it's set up that way. I have no idea why. Whenever you read from a file, you need to put it in a try statement so you can catch a file not found exception. So while reader.has next names.add. This is nothing really new. This doesn't have to do with project Euler at all. This is just reading from the file. It's quite boring. Then down here, catch file not found exception. And we're not going to do anything if it finds an error. Okay, so now we have all the names in the list, but it's not in alphabetical order, so we're going to want to sort that list. Sort the names list, sorry. We're going to make that method in a little bit. So next we want to find the name store of those. So in I equals 0, I is less than names dot length, I plus plus. It's actually size. And we need a name total first of all. And name total equals get name value names dot get index or I. Sorry. Next we need to multiply it by the place it is in the list as described on the website. So we're going to need to do I plus 1 because this goes from 0 to n minus 1, and we want, in reality, we want it from 1 to n. So sum plus equals name total times I plus 1. And down here, we're just going to system out. The total is percent. There we go. Okay, we're going to make the getName value method first. Public static int getName val, and we're going to take a string name. And the way we're going to do this is by manipulating the fact that all characters have an ASCII value, which is just an integer value assigned to them. All symbols and characters do. My apologies. And it's different for upper and lowercase. So what we're going to do is take the the uppercase one and find the a value and subtract 1. And I'll tell you why in a second. So final int, we'll call that beginning value. Integer.value of a minus 1. The reason it's minus 1 because a is probably about 65, and if there's a name with an a in it, which there is, it will be 0, but there's no zeroth place in the alphabet. A is the first letter, so you want to do minus 1. So a minus the beginning value will be 1, which means it will correlate to the first letter of the alphabet. That was a mouthful. Now we need a total that will equal 0. For int I equals 0 is less than name.length I plus plus. Total will integer.value of name.car at I minus big val. And this is just taking the individual characters of a name, subtracting the beginning value to find the place in the alphabet it is, and then adding it to the total, and it will return it to give the name total. But first we need to return something, so we will return total. So the last thing we need to do is do a sort, and I will be showing you guys the quick sort. It's very, very fast, and it's perhaps one of my favorites. Algorithms are one of my favorite things to do. So first we need public static void sort of type list, and then we're just going to put it in another sort method. So list 0 list.size minus 1. Yeah. The reason you'd want to do this is, say you're making a program for a consumer. They do not need to see, well, they're going to need to use this method, but they do not need to use like the other helper methods used with the quick sort. This is supposed to be encapsulation. It's so that the consumers don't need to know what's going on, so you don't let them know what's going on. So all these will be private. This is what happens in the ideal case. So sort list type list and low and high. The 0 right here is the low number. The index minus 1 is the high number. I didn't put a static nor a void in there. So what we want to do in here is, since this is a recursive method, we want to do high. If high is less than or equal to low, just return. Otherwise, we want to partition it, which just means divide, because quicksort is a divide and conquer algorithm. Partition, list, low, high, partition. There we go. We'll make that method in a second. After we partition it, we want to sort it again. Mid -1, sort lists, mid +1, high. There we go. Before we do the partition method, we're going to make two helper methods. One for determining if, well, hold on, let me write this out first. Private static Boolean less string. This will determine if the first one is less than the second one. Let's see code graphically. So return first compare to nor case second is less than 0. If the first is less than the second, it will return true. If it's equal to or greater than, it will return false. Then we need an exchange method. Static void exchange string list int low, int high. So whenever you exchange something, you want a temporary variable. This is common for all sorting algorithms. Temp equals list.getLow, and then we want to say list.set. We want to set high. Oh, sorry. We want to set low equal to list.getHigh, and we want to set high equal to temp. There we go. Now we can move on to the partition algorithm. Private static int partition is going to take a list of type string, int low, int high. There we go. Here comes the fun stuff. This is going to get really confusing. I'm sorry, guys. Just bear with me and know that you are in safe hands. Okay, we need a new low here. We're just going to set that to low. A new high equal to high +1. The name will equal the first value in the list, and it's just going to check them. So while true, this will continue on until we meet a condition. We'll write the condition later on in this loop. So what do we want to happen? Make sure your parentheses line up there. Okay, this is going to keep happening while the lowest value is less than name. And this is just going to keep incrementing this increments variable. Notice we need to do the same except for the top. While name is less than list.get minus high. Actually, it's new high, sorry. If new high equals low, we want to break. The reason we needed a new low, new high is because we wanted to keep low and high, the original values, static, so we can compare them. And then down here will be our condition statement. If new low is greater than or equal to new high break, because else it will go on forever and that won't be fun. And down here we will exchange all values we need to exchange, which is new low and new high. And then after this loop breaks out, we need to do one last exchange, and that will be exchanging low and new high. If I can spell right. And then we're just going to return new high. That is the quick sort method. I hope you guys liked it, but this isn't about this. This isn't about that. Yeah. So we are done writing this. The total is that number right there. We will check that right now. That is true. I thank you guys for watching. We'll go over this again real quick. This just reads from the file. We needed to sort the names using the quick sort method, which incorporates all that right there. I didn't explain it much because this is a method, or this is a tutorial about the actual problem. We needed to get the name total, so we did that by taking the ASCII values and subtracting them from the beginning value right here. That got the place in the alphabetical list. We added it up to get the name total, and then we needed to multiply that by the place in the actual list it was. So times the index plus 1, and we just added some, and that gave us our total of this huge number right here. Thank you guys for watching again. Please leave a like if you liked it. If you have any questions, feel free to leave a comment in the comments below. Me or someone else will get back to you, or someone else or I will get back to you. I will leave a visualization of the quick sort in the description below. Subscribe if you haven't already, and thank you.